Hello, accelerated chemistry students. This is Ms. Krista Foley, and this is your Chapter 15, Section 3 video notes all over heterogeneous aqueous systems. So let's first start talking about suspensions. A suspension is a mixture from which particles settle out upon standing. Suspension differs from a solution because the particles of a suspension are much larger and do not stay suspended indefinitely. A solution is a homogeneous mixture. Suspensions are heterogeneous mixtures, but at least two substances can be clearly identified. The difference between a solution and suspension is easily seen when the mixture is filtered. Solutions will pass through the filter paper. Suspensions, the particles will be removed with the filter paper. Now let's talk about colloids. A colloid is a heterogeneous mixture containing particles that are spread or dispersed throughout the dispersion medium, which can be a solid, liquid, or gas. Colloids have particles smaller than those in suspensions and larger than those in solutions. The colloid particles cannot be retained by filter paper like a suspension and do not settle out with time. Let's talk about the Tyndall effect. You cannot see a beam of sunlight unless the light passes through particles of water, mist, or dust in the air. These particles scatter the sunlight. Similarly, a beam of light is visible as it passes through a colloid. The scattering of visible light by colloidal particles is called the Tyndall effect. And as you can see, you will not see the particles through a solution because they are so small. You will see them in a colloid and a suspension. The colloid particles are larger than those found in a solution, but smaller than those found in a suspension. Suspensions also exhibit the Tyndall effect. The particles in solution are too small to scatter the light, though. Let's talk about Brownian motion. Flashes of light are seen when colloids are studied under a microscope. Colloids spark because the particles reflecting and scattering the light move erratically. The chaotic movement of colloidal particles was first observed by the Scottish botanist Robert Brown and is called Brownian motion. Brownian motion is caused by collisions of the molecules of the dispersion medium with small dispersed colloidal particles. These collisions help prevent the colloidal particles from setting. Coagulation. Colloidal particles also tend to stay suspended because they become charged by absorbing ions from the dispersing medium onto their surface. Absorption means they adhere to the surface. All the colloidal particles in a particular colloidal system will have the same charge, although the colloidal system is neutral. The repulsion between like-charged particles prevents the particles from forming heavier aggregates that would have a greater tendency to settle out. A colloidal system can be destroyed or coagulated by the addition of electrolytes. The added ions neutralize the charge in colloidal particles. The particles can clump together to form heavier aggregates and settle out from the dispersion. Let's talk about emulsions. An emulsion is a colloidal dispersion of a liquid in a liquid. An emulsifying agent, essentially, for the formation of an emulsion An emulsifying agent is essential for the formation of an emulsion and for maintaining the emulsion's stability. Oils and greases are not soluble in water. However, oil and greases readily form a colloidal dispersion if soap or detergent is added to the water. That is because soap has a side of it that is attracted to the oils and greases, and it also has a side of it that's attracted to the water. One end of the large soap or detergent molecule is polar and attracted to water, and the other one is nonpolar and attracted to the oil and grease. Soaps and other emulsifying agents thus allow the formation of colloidal dispersions between liquids and do not ordinarily mix. That's why we use detergents and soaps to wash our hair, our skin, our clothes, because we have those oils, dirt, and grease, which are nonpolar molecules, but they will never be rinsed away with water. If you ever rinse your hair with water, it'll still feel greasy. You need that soap in there to attach to the oil, dirt, particles in your hair in order to rinse them out. And that is the end of your Chapter 15, Section 3 notes. And as always, all the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition textbook resources CD and pearsonchem.com. Thank you so much. Have a great night.